So next topic is next unit is 6th unit. That is we are going to study about network theorems. So network theorems we are going to study about the four theorems. The first one is the Thevenin's theorem, and second one is the Norton's theorem, the maximum power transfer theorem, and superposition theorem. So why we are going to study the network theorem? The first thing is that to find the load current. Okay. So there is a load is there, is a load. So I am interested to find the current in the load, the first one, right? I want to know how much current is this load is handling. And the second thing, any complex circuit can be easily solved by using these theorems. Complex circuit can be easily solved by using network theorems. That is the second advantage. Okay. So we see that here. First we are going to study Thevenin's theorem. What actually is Thevenin's theorem state that? So you see that any linear two-terminal network, you give any linear two-terminal network, it means this all follows the Ohm's law, all elements, right? So the statement says that, see, this is any kind of circuit, this is any linear two-terminal network. If I can draw like this, or many resistors, it is just a complex network. This is like a complex network. So this complex network, so what I am going to do this, complex network means a linear two-terminal network. So that is connected to a load like this, right? There are two terminals and A and B. Then across the terminals there is a voltage and a load is connected here, right? The current is flowing into the load. I want us to find current in the load, and the second thing, and to solve the circuit. So complex circuit can be solved by the Thevenin's theorem. What actually statement says that Thevenin's theorem states that a linear two-terminal, this is the linear two-terminal network, can be replaced by an equivalent circuit consisting of voltage source VTH in series with a resistor. So what I do, this linear terminal network I am going to replace, okay, by an equivalent circuit. This is an equivalent circuit, okay, consisting of that equivalent circuit consisting of voltage source, that is a VTH, this is a voltage source, in series with a resistor RTH, right? Where this VTH we call the open circuit. This VTH we called it here, VTH we call it a open circuit voltage. We have to find the open circuit voltage like this. I am just going to connect like this, right? So this is the open circuit, right? And at the terminals, and the RTH is the input. This RTH is the input or equivalent resistance at the terminals when independent sources are turned off. Independent source means, you know, that's independent source means a voltage source, okay, and another one is the current source. These are the independent sources. Dependent sources are shown in the diamond shape, right? What is saying is when independent sources are turned off. So when they are turned off, so voltage source when you turn off, it becomes a short circuit, and the current source become open circuit. And this one will be the open circuit. That's you have to remember. Right. Very simple. Any complex circuit is given. So what you will do, simply you have to replace like this VTH, okay, and connect it once. RTH you have to connect it like this, okay, and find what is VTH and RTH. And finally resistor which I have removed it, you connect it here and find how much current is flowing through resistor. Alright. First you are interested to find the current flowing through the load resistor. So they remove it and replace this linear terminal circuit, this complex circuit into voltage source in series with the current source, right? So here VTH is equal to VOC, open circuit voltage. RTH means the total resistance of the circuit when the independent sources are turned off, right? If we are dependent sources, we should not turn off. Anyway, we do one problem and easily to understand. Here what happened, this is a complex circuit. So what is saying, find the Thevenin equivalent circuit of the circuit shown in figure. Okay, this is the Thevenin circuit and this is the 6 ohm and 16 ohm. Individually you have to find out this one, right? So here you see that this is the circuit we have given. So what they are going to say, find the Thevenin equivalent circuit. What is the Thevenin equivalent circuit? This is the Thevenin equivalent circuit. First you have to convert. It's a very simple, any complex circuit you take, right? You just convert into this complex circuit, just convert into one series resistance and one voltage source with the series resistance. So this one is actually VTH, Thevenin circuit, right? So this one is equal to VOC, open circuit voltage, you can write, right? After converting this, simply you have removed it, right? This load resistance you are interested to find, you remove it, and this circuit, this entire circuit, we just transform into this. Okay, this IAB I am going to put as it is. Alright. Now you have to find what is the VTH and RTH. Right. You take this circuit. First I am going to find RTH. What is RTH? To find RTH, all independent sources should be turned off. If voltage source is there, okay, what happened? It is short, it is current source is open. You just see that now this is the current source, this is a voltage source, so what happened? It becomes short. Then resistor is there, this is the 4 ohm, okay, and this is the 12 ohm, right, and this is the open. So this is what happened, this is the open. Since the current source is open, there is a 1 ohm, alright. So this is how we are going to find the RTH, total resistance, or sometimes we say RN also, we can say this one, right. now what happened? So these two resistors are parallel. These two resistors are parallel. So how can you find it? 4 into 12 by, okay, 4 into 12 by 4 plus 12, 48 by 16. So you will get 1. This is 4 just 16, 4 1 4 2, 4 1 4 3. So that is this is 3 ohm, right? 3 ohm, and this is the 3 ohm, and I'm already 1 ohm is there. So this is the total resistance is here. This is RN or RTH, 1 plus 3 is a 4 ohm. So this is a 4 ohm. We call it a 4 ohm. Okay. Next we have to find the VTH. What you have to find that to find the VTH? Okay. You just apply KCL, the same circuit. Okay. What I did here, I just going to find current I1 and here current I2. Okay. Then I can easily find what is the VTH. Okay. To find this, what happened? First you have to apply the mesh analysis. So when you apply the mesh analysis, what happened? You get minus 32 plus 4I1. I just am going to write in the red pen. Okay. Or I can erase it and it will be easy to solve here. It will be very easy to solve. So 4I1, right? This is a 4I1 plus when counted to 12 ohm. So 12 ohm into this is the I1, the same time I2 current also flowing in opposite direction, minus I2 is equal to 0. So what happened? It was 32, 4I1, this is the 12I1 minus 12I2, okay, is equal to 32, right? What is this one? 16I1 minus 12I2 is equal to 32. So 4 ja 16 and 4 3 12 8. Okay, this is the equation. One equation you got it right. Now you know that there is in the loop there is a current also there. So simply you put I2 is equal to minus 2 ampere. So you got I1 and I2. Okay, you got I1 and I2. So I2 is, so what is it? Very easy to find I1. So this one is a 4I1 minus 3 into minus 2. This is a 8. 4I1 is equal to 6 8, and 4I1 is equal to this one is a 8 minus 6, that is a 2. Then I1 is equal to 2 by 4, that is 0.5 ampere. I1 is equal to 0.5 ampere. I1 is equal to 0.5 amps. Right. So you know I1 and I2. So this is, what is the voltage drop across this 12 ohm resistor? Voltage drop of the 12 ohm resistor is, so 12 into I1 minus I2. So 12 into, what is I1? I1 is 0.5. Okay, minus, already minus is there, that is a 2. So 12 into 2.5. How much 12 into 2.5? That we have to find it. Then it will be very easy to find. Okay, so that can be calculated very easy. 12 into 0.5, that is you get around 6. So this is a 6 ohm. Okay, so VOC means here the voltage drop across this resistor is equal to this. Okay, that is a 6 ohm. Sorry, 6 volts. 6 volts. Okay, you got Thevenin's or open circuit voltage is a 6 volts. This is 6 volts. This is 6 volts. Right. Now we know 6. We know that 4 volts. Right. Now I can easily find the load current. Okay. So what I do now? Now I am going to just replace this. So you know that this is your current voltage source. That's, you know that 6 volts, and this one is the 4 ohm. Okay, and you replace your resistance. The resistance, you know that is the first I am going to 6. This is a 6 ohm, and this is the I. So what is the I is equal to V by R. So 6 by 10. So this is a 6 by 10 ampere. The next one is I am going to replace it with the 16. So you will get I is equal to V by R, 6 by 20. So this is your load current. This is how you are going to find the load current by using Thevenin's theorem.